All right, we're moving on to chapter 6, section 5, and we are doing equations containing radicals. Remember, radicals are square roots, and now we're solving them. Equations are equal signs. Our essential question today is, can you solve equations containing radicals? So let's take a peek at example 1. Notice we have the square root of 2a minus 1 minus 3 equals 0. The first thing we want to do is get rid of what's around the square root. So I'm going to add 3 to each side. So we have 2a minus 1 under the radical is equal to 3. Now, to get rid of that square root, we do have to square each side. What happens is this square root cancels out with this square. So on the left side, we now just have 2a minus 1, and on the right side, we have 3 squared, which is 9. From here, we're just going to solve like an equation. We could add that 1 over, so 2a is equal to 10, and a is equal to 5. Now, I would encourage each one of my students to plug it back into the original. So we would always want to check. And I have 2 times 5 minus 1 minus 3 equals 0. 2 times 5 is 10, minus 1 is the square root of 9, minus 3 equals 0. Yeah, 3 minus 3 is equal to 0, so this one checks through. So the answer is A equals 5. Now I tell my students to get used to checking because sometimes they do not check through. Let's move on to example 2. Notice here, I already have a square root is equal to x. So we're going to do the exact same thing by squaring each side. And the square root squared. The left side will just have 7x minus 12. And on the right side, I do have x squared. Now, I get my students used to saying all quadratics have to be equal to 0. I would bring all of these over here to keep my x squared positive. So I'm going to put my 0 here. When I subtract 7x over and I add 12, I get x squared minus 7x plus 12. And you guys are complete rock stars at factoring, so 0. What are the factors of 12 that add up to be negative 7? That would be negative 3 and negative 4. So remember that we can make each equal to 0. So I'm going to do that. So I'm going to take x minus 3 is equal to 0, and x minus 4 is equal to 0. So when I solve here, I get x equals 3. And when I solve here, I get x equals 4. And like before, we do want to make sure we plug it back in to check. So I want you to check to see if they both check through. And in this case, 3 and 4 both check through. So my answers are x equals 3, x equals 4. All right, let's do one more because these turn into crazy problems. So just like before, to solve example 3, 3 times the square root of x plus 1 minus x equals 0, we're going to go ahead and add x over. So we have 1 plus x. Now, we can divide by that 3, but that's just going to divide and then we're going to multiply it back. So I tell my students from here, we're just going to go ahead and square each side. So remember when I take 3 squared, that becomes 9, and the square root will just get rid of x plus 1. But remember here, this square is telling me to FOIL, so I like to write it out to see it. So first terms is 1. Outers and inners, 1x and 1x is 2x, and last terms are x squared. And then we get to distribute through, so we're going to distribute this 9 through. 9x plus 9 is equal to, I'm going to put this in order because I like to see it in the quadratic order that I'm used to, x squared plus 2x plus 1. And just like before, I'm going to solve for 0. Make it equal to 0, so I'm going to bring the 9x over, so 2x minus 9x is negative 7x. And I'm going to subtract the 9 over, so 1 minus 9 is -8. What are the factors of -8 that add up to be -7? So I know this will be an x minus 8 and an x plus 1. And we'll go back up here, and we're going to set each of those equal to 0. X minus 8 equals 0. And x plus 1 equals 0. And once again, we want to check both of them through. Now, I've done this problem previously. 8 and -1 check through, but just a reminder, we want to check them back through the original. So when we're checking them through, we want to go back to the actual question that was given, and instead of putting in an x, we're going to put in 8 and 8, and then instead of putting an x again, we're going to put in -1, -1.